Hello, it's KP the Math G, and I am here to discuss a few things about approximating area. The reason that we approximate area, well, we finally learn what the actual area is by integrating. Why do we need to know about area? Well, area, when we figure this out, really, I hate to say area under a curve, but that's what we do. We find the area under the curve. But what does it represent? It represents, say for example, if you have the derivative, something like this that represents the rate that water is going through a pipe, and it's going into a bathtub. Okay, the rate that the water goes through the pipe, when you integrate that, okay, you are looking at amount of water in the tub. After you integrate the rate that the water is going through the pipe, you get the amount of water. Okay, it's kind of like if you integrate feet per second, you get feet. Okay, the area under the curve represents, say, feet or amount. How far did you go? A quantity. Okay, and so that's what we're talking about here. Okay, most of the time it does. Okay, and so we start off looking at approximations using rectangles, mainly rectangles, and then later on trapezoids. What we're looking for is this area. Now, here's what we're going to do. We're going to consider f at x is equal to 16 minus x squared throughout all of these videos. So if you will, if you can, if you have time, please look at all of the videos. There's 3 parts to this. Okay, and maybe a part 4 that involves a table. Maybe a parts 4 and 5 that involves a table. So at least for right now, we're looking at part 1. On part 1, we're going to look at both the left and the right hand rule. Part 2, we're going to look at the midpoint rule. Part 3, we're going to look at a trapezoidal rule. Okay, and so first of all, let's look at the left hand rule here. Okay, what are we talking about here? Left hand rule and so on. Let me erase this because I'm going to need all the room I can possibly muster on this board here. Okay, so right now we are looking at the left hand rule. Okay, now what we need is 4 triangles, and let me just kind of give you an idea of what we're doing here. I want 4 triangles now, and we're going to find the area of each one. Okay, so starting on the left hand, okay, left hand, we're going to always start at the leftmost side. 0 is the leftmost number. Alright, we're going to go, and we got to figure out, well, how many partitions do we need? We need 4. Alright, here's how we do it. It is actually B minus A. This what we call delta X. And I'm going to explain all this, what delta X means. We're not going to leave you out there in the cold enough outside. Okay, over N. Alright, now N is 4. We want 4 rectangles. Okay, so 4 rectangles. Now, how wide? This is how wide. How wide are the rectangles? How wide is always going to be delta x. Since we're putting 4 triangles in here, we want to figure out how wide they need to be. Now B happens to be 4 and A happens to be 0. If this had been from 1 to 4, B would have been 4, A would have been 1. So B minus A, 4 minus 0 over 4, is of course 4 over 4, which is 1. Delta x equals 1. I could have set this up for 8 triangles, but that would have been a little bit more to swallow at this point. This delta x being 1 is really going to be nice for all of us. Okay, if I had delta x being a half or delta x being a fourth, we would start off with fractions, and really and truly we might lose the idea behind doing this, and we'll be concentrating on the numbers instead of how to go about doing this. So alright, so let's go ahead and draw the 4. Since delta x is from here to here, delta x is from 0 to 1. Well, since delta x equals 1 unit, this is how wide the triangle is. Okay, so delta x is 1. So from 1 to 2 is 1. From 2 to 3 is 1. Delta x is 1. Delta x is 1. So this is the width. Okay, now remember, let's look at a triangle in the first place, a rectangle rather. I keep saying triangle. That's not drawn the scale, of course. Okay, now delta x is the width, and you have the height, right? Alright, sometimes base times height, sometimes length times width. That's the area of this. Okay, so the area of a rectangle is length times width, or so in this case it's the width times the height. Width times the height. Okay, we're going to get into, and this, remember, the width is we already know that the width is 1 unit. Okay, so just kind of bear with me as we talk about this just a little bit. Let's form the triangles one by one, and I wish I had a ruler. I could make these a little more accurate, but let's see if we can go straight up from 1. Not going to be exactly straight. Alright, well, let's start at the leftmost side, 0. The leftmost, we're going to make this a side here, the y-axis a side, and we're going to come across. Oh, by the way, this is the graph, by the way, it's part of it, of 16 minus x squared. It goes on this way too to -4. Alright, it crosses the x-axis at -4 and at +4, but we're only looking at it from the closed interval from 0 to 4. So therefore we're only looking at this part right here, the area of this part bounded by the x-axis and the y-axis and the curve itself. We're actually looking for this area right here, all this area. Okay, but needless to say, we're not going to do it haphazardly. We're going to do an approximation, and we're going to use rectangles to do that. Okay, starting at the left side, you go 1 unit over, delta x over, and come straight down to 1, like that. Okay, and as you can see, this is going to be an approximation because this is above, this little white portion right here, that's above the curve itself, isn't it? Okay, all of these rectangles are going to be a little bit above the curve. That's going to be what we call an over approximation. Okay, alright, Now, let's go from 1. Where this crosses right here, I'm going to put a dot right here. Alright, I'm going to go exactly 1 unit over, 1 straight across like this, and come down to 2. Alright, bear with me as I draw this thing. Come down to 2. Alright. Well, it's not straight, y'all. Somebody can draw straighter than I can, I'm sure. Okay, right there is where it crosses this pink curve. Okay, y is equal to 16 minus x squared right here. Okay, I'm going to kind of make sure we see those. And we're going to come, I'm going to erase the word the here. Okay, we're just going to have to come on and use this. Alright, here we go. We're going to come straight across. And we're going to come straight down to 3. See, we want a rectangle. We want, this is definitely not straight, but we're going to imagine that it's straight, right? Okay, see where that crosses right there? We're going to put a dot there, a point there, and gotta erase this how wide it is. We're just going to come over until we get to 4, and we're going to come straight down right here. Whoa, maybe we should go out a little further, I don't know. Okay, somewhere right in there, and come down to 4. Okay, like that. Now that's for, now these rectangles, if this were drawn to scale, if I'd spaced these out just right and used a ruler and everything, these would be the exact same width each time, but you can see that 3 and 4 are a little bit further out, but still they're only 1 unit apart. Okay? So here's what we do. We got to get, we have the length, this is the width. Remember, the width is delta x, which is 1. We already know that all of these delta x's are 1 times this height here. So we'll call this height 1. And then this delta x times this height here that comes up to here. Alright, so this is height 2. And then this delta x, which is 1, times this height, well, we're going to go up right here, times this height here, yeah, right here, height 3. And then this delta x here, times this height here, this is height 4. Okay, now, this, think about this now, y is the height. H1 is actually equal to Y1, and this is really Y2, this is really Y3, and this is really Y4. Isn't f at x equal to y? Y. Is it, can't we not say this is y is equal to 16 minus x squared, which is the same as the height? Alright, the height is y, which is 16. The height is y, which is 16 minus x squared. Alright, so this is 0. So this point is, yeah, f at 0. That's the height of this rectangle here. The height of this rectangle is here. This is L at 1. This is x is 1. This makes this L at 1. Okay. This is 2. X is 2. This makes this point L at 2. Okay. This point right here is where this is x is 3. This point right here is L at 3. These 4 heights, we're going to sum them up. Okay, we're going to sum them up. We're going to add all of these up. Let me erase all of this because we need all the space we can get. Okay. Now, that is called the left-hand rule. Can anybody see why that's left? Because we started at 0 and we went to from 0 to 1, from 1 to 2, from 2 to 3, from 3 to 4. We don't have a point here because it's not resting on this curve, is it? So we can't have an F4. You see that? We can only take points that are on the curve, and we chose the leftmost side because we're looking at the left-hand rule. Alright, when we do the right-hand rule, we're going to look at the right-hand side first. Okay? As you can see, these rectangle areas extend into here, and here, and here, and here. You can see that this area is going to be too much. When we add this area, so area 1 plus area 2 plus area 3 plus area 4, when we add all of those areas, it's going to be too much area under the curve. We're looking for just the area under the curve, so that's why we're making it, calling it an approximation. Okay? Lucky for us, the left-hand rule is not the only rule we have. Okay? Alright, so let's look at this. Let's see what we've got here. So let's see. We're going to add up. We're going to add up all of these for delta x is 1, the length times the height, L at 0, 1 times L at 1 plus 1 times L at 2 plus 1 times L at 3. And by the way, since 1 is a common factor, we can just say this is actually delta x. Alright, so delta x times L at 0 plus L at 1 plus L at 2 plus L at 3. Okay. Alright, let's figure out what L at 0 and L at 1 and L at 2 and L at 3 are. Alright, L at 0. If I plug 0 in, so L at 0 is 16 minus 0 squared, which is just 16, isn't it? So L at 0 is 16. Plus sign, we're adding this, so this area is 16 square units. We've got this area. Okay? This area is L at 1, so I'm just going to plug a 1 right here. L at 1 is 16 plus 1 squared. Well, 1 squared is 1, so 16 minus 1 is 15. Alright, so L at 1 is 15. That corresponds to 15. Alright, let's see what L at 2. We're going to add this up. L at 2. Okay. Let's plug in the 2 right here. Alright, right there, right there. Oh, 2 squared is 4. 16 minus 4 is 12. 12. So this is 12. Alright, need some room here. Alright, L at 3. L at 3 is equal to 16 minus 3 squared. 16 minus 9 is 7. So plus 7. The height of this is 16 units. Agreed? The height of this one that we're taking the area of area 2, is 15 units high. The height of this one is 12 units high. Okay? And the height of this one is 7 units high. So a 1 by 16 plus a 1 by 15 plus a 1 by 12 plus a 1 by 7. Right? That's how you do area, right? The area of rectangles. Alright, so we multiply that by 1, we still get 1. Let's add these up real fast. I want to say we get 50. 16 plus 15 is 31. Plus 12 and 7 is 19. 31 plus 19 is 50. If we were to figure out or integrate this, which we will learn how to do this later, we're going to find the actual amount after the end of, well, so you're going to have to tune in. At the end of each one of these, I may try to still do it, but and show you the exact value in case you're not able to get on and do this. Alright, that's the left hand rule here. Okay, let's do the exact same thing. Now remember, this is 50 here. We're going to just flip the board over and we're going to do the right hand rule now. Okay, so we got the left hand rule done. That's checked off. Okay, so now we're going to go about doing the right hand rule, which means that instead of starting from the leftmost point, 0, we're going to start at the rightmost point, 4. Okay, let's draw the picture again. Okay, so we're going to draw this again like this. I'm going to say, wow. Let's make it look a little more professional looking. Okay. I mean, I do like to be a little bit neat, okay? Let's see here. We'll just use this color here. Alright, let's do that. Whoa, okay. And as you can tell, this being 4 way over here and 16 right here, this is slightly higher than this. There's no way that this ratio is 4 to 16, is it? 4 is more right about here, but we want this out here for emphasis sake. So that's why I moved the 4 way out here. Here's X, this is Y. Okay, so let's draw the picture again, and let's see what we've got here. Alright, here we go. We're going to draw this in red. Okay, let's see right here. Okay, now again 0, and since we already know what delta x is equal to 1, and we know that the function is f at x is equal to 16 minus x squared. We still got to remember that we're still using the exact same thing. And remember, we're looking at the closed interval from 0 to 4. We're only forming 4 triangles, so each triangle delta x is equal to 1. Okay, so what does that mean? Delta x again. Delta x means that's the width. Okay, alright, so let's see, 1, I should have put 2 right in the middle here, 3 here, 4 there. Okay, alright, I like to use different colors if I may. Alright, now let's draw the triangle. This time we're going to start at 4 and move. Now listen, 4 starts, there is no, the curve ends on 4 at 0. So really, do we even have a rectangle from 3 to 4? The answer to that is no, since we started at the right. So remember, we're doing the right hand approximation. I don't know if they call it hand, but the right hand approximation. Alright, so we got to start from the right. We make our triangles from the right. Remember, the last time we made our triangles from the left, this time from the right. So this time we're going to go up until we intersect right there. There's the point right there. By the way, remember this is 3. What is this? Yes, that's right, F3. That's the height of this one. This one is actually F4, but we already know that F4 is at 0. Okay. Let's draw a triangle straight across here and come over here until we meet 2. 2 is going to come straight up until it comes, oh boy, that is so, I mean, I've seen crooked highways straighter than that. I drove on some just the other day. Okay, here we go. Okay, right about there. We're just going to say right there. This is 2. And then right here, this has to be F at 2. Okay, let's go across again, straight across because we want a rectangle. Okay, straight across, straight up, 1 straight up, whoa. And we're going to always touch the curve right here. So this is F1. And notice that we're not drawing anything for F0. Okay, so really when we do a left-hand rule, we're considering F at 0, F at 1, F at 2, F at 3. Here we're considering F at 1, F at 2, F at 3, F at 4. If you want to go backwards, F at 4, F at 3, F at 2, F at 1. Okay, just make sure you understand the difference in those rules. So again, delta x is 1. We're going to sum all of these up. And I guess I should put a Riemann sum like that. I equal 1 to 4 like this. And then Fx of I delta x like that. I mean, that's probably the right way. This is called a Riemann sum. A Riemann sum. And don't ask me to spell that because I would fail on that one, okay? Alright, we're summing these 4 rectangles up. And really and truly, we only have 3 of them because this one here, it's kind of flat, isn't it? Well, we're going to use it. That's what we're going to do. And notice that this time, I want you to notice something here. We're going to flip the board back over, but notice that there are no gaps above, but we do have gaps below here, don't we? We have a major gap here, okay, but we do have gaps below. Okay, I need to draw this straight across here. And look here, this is an under, what we call an under approximation. Notice over here the difference between, in this particular case now, it depends on the curve. This curve is going downward, okay? F is decreasing here, so we're going to have an underestimation here, okay? Under approximation, okay, of these areas from the right-hand side, but now on the left-hand side we had too much. These were above the, see that? Each one of these corners were above. This is well above here. Okay, but now here, this is below. Okay, right here, these are below. Alright, that's not always the case just because we are looking at the right-hand rule. It depends on the curve. Okay, the curve may go up, and so we got a different story. Okay, alright. Let's take a look. Now delta x is 1. We're going to sum that up. Now remember, we're saying F at 1. We're skipping F at 0 because we're not looking at the leftmost side. We started from the rightmost side. F at 1 plus F at 2 plus F at 3 plus F at 4. And remember, F at whatever we're plugging in here. Remember now, 1 times all this is just this. F at 1, we already know these 3, don't we? Isn't elf at 1 15, and elf at 2 is 12, and elf at 3 is 7. But now elf at 4, we haven't figured that out, but you can see very quickly. And again, we could plug these back in. Elf at 1 is 16 minus 1 squared, which is 16 minus 1, which is 15. Alright, that corresponds to that one. Elf at 2 is 16 minus 2 squared, which is 16 minus 4, which is 12. There's the 12 for that one. Alright, elf at 3 is 16 minus 3 squared, which is 16 minus 9, which is 7. Alright, so that corresponds to this one here. Alright, so elf at 4 is 16 minus 4 squared, which you see we didn't have a rectangle in the first place. Well, this is 16 minus 16, which, by the way, is, as you well know, is 0. The area is 0, as it should be right here.